Hello everyone. Today we are going to learn alpha, beta and gamma decay in 15 minutes. My name is Aimee Mahira binti Zulkifli and my metric number is 17089-296/3. So first, let's see the learning outcomes. At the end of this lesson, students should be able to explain with a sample the decay equations for alpha decay, beta decay and gamma decay. And the second one is write the decay equations for alpha decay, beta decay and gamma decay. So in Form 4 chemistry, you have learned about the atomic structure. So now let us do some recap about the structure of an atom. So here is the structure of an atom. The center one is known as the nucleus. The nucleus contains protons and neutrons, while the outside of the nucleus or in the shell, the moving one is known as the electrons. As for the atomic symbol, the X is known as the chemical symbol, for A is the mass number, and for Z is the atomic number. So what is the meaning of the mass number and atomic number? Mass number is the total of number of protons and number of neutrons in the nucleus. For atomic number, it is the number of protons in the nucleus. Number of atoms can be calculated or can be obtained by subtracting the mass number and the atomic number. Radioactive decay. It is a random and spontaneous process where an unstable nucleus emits radioactive radiation until the nucleus becomes more stable. So in this diagram, it shows an unstable nucleus, which is known as the parent nucleus, emits radioactive radiation in the form of alpha particle to become more stable, which is known as daughter nucleus. Now, let me explain to you what is radioactive radiation. So, radiation is the emission or transmission of energy in the form of wave or particles through space or through a material medium. So there are three types of radioactive radiation, which are alpha particle, beta particle, and the last one is gamma ray. Now, let me introduce you alpha decay. An unstable nucleus releases an alpha particle to become a more stable nucleus of a new element. So here is the structure of alpha particle and its symbol. An alpha particle is identical to that of a helium nucleus, which consists of 2 protons and 2 neutrons. As for general equation for alpha decay, we need to write the atomic symbol for the unstable atom and more stable atom, plus with the symbol for alpha particle. For your information, alpha particle is the most massive particle emitted by radioactive nuclei. So it has highest ionizing power. So what does it mean by ionizing power? Ionizing power is the ability of radiation to ionize other molecules or atoms. And it also has the lowest penetrating power. So penetrating power is the ability of radiation to penetrate matter. So let me show you the diagram for the process of alpha decay. So here is the parent nucleus, which is unstable nucleus, undergo alpha decay and produce daughter nucleus and emit an alpha particle. So the daughter nucleus will become more stable than the parent nucleus. So now let's see the example of alpha decay. So here is the decay equation for radon-222, which undergo alpha decay and produce polonium-218. So here, radon is the parent nuclide, which is unstable nucleus, and polonium is the daughter nuclide, which is more stable nucleus. An alpha particle have a mass of 4 and a charge of +2. So when an atom loses an alpha particle, the mass number decreases by 4 and the atomic number decreases by 2. In other way, we can say that an alpha decay is the loss of an alpha particle. Now let's learn how to write decay equation for alpha decay. So actually we can deduce the mass number and atomic number of the unknown daughter nucleus because the equation must be balanced. So what does it mean? Okay, first let me show you the decay equation for thorium-232. So here is the equation. This is the parent nucleus and this is the unknown daughter nucleus. What it means by the equation must be balanced is that the total of mass number and the atomic number on the right side of the equation must equal to the total of the mass number and atomic number on the left side of the equation. So to find the value of x, which is the mass number, and y, the atomic number, for the unknown daughter nucleus, we can perform a simple math. So here x plus 4, which is 4 is the mass number for alpha particle, equals to 232, which is the mass number for the thorium. So the value for x is equal to 228. Same goes for y. Y plus 2 is equal to 90. So 2 is the atomic number for alpha particle and 90 is the atomic number for thorium. So y is equal to 88. To know which element does the unknown daughter nucleus belongs to, we can refer to the periodic table. So the unknown daughter nucleus for thorium-232 is radium-228. Next is beta decay. So beta decay occurs when a neutron changes into a proton and an electron. The proton is retained by the atom while the electron is lost. So lost electron is known as beta particle. So beta particle is an electron released by an unstable nucleus of an atom which has a -1 charge. So here is the structure for the beta particle and its symbol. So the general equation for beta decay is, so this is the parent nucleus, this is the daughter nucleus, and this is the symbol for beta particle. So in daughter nucleus, protons stay in here, while this one is beta particle or the electron. Beta particles are less massive than alpha particle, so it has lower ionizing power and higher penetrating power. However, it can be stopped by a sheet of metal such as aluminium. This diagram shows the process of beta decay. As I have explained before, parent nucleus will produce daughter nucleus plus beta particle. So daughter nucleus will be more stable compared to the parent nucleus. Next, we will see the example of beta decay. So here is the beta decay equation for iodine-131. So iodine-131 undergoes beta decay and produce xenon-131 and beta particle. So we can see that after beta decay, the mass number for xenon and iodine are the same. But for the atomic number, it is increased by 1. So we can say that in beta decay, it involving loss of an electron. Okay, now let's learn how to write decay equation for beta decay. So the steps are still the same as we want to write the decay equation for alpha decay. So let's see the decay equation for radium-228. So here is the parent nucleus and this is the unknown daughter nucleus and this is the beta particle. So to find the mass number and atomic number for the unknown daughter nucleus, we can perform a simple math. So x plus 0, 0 is the mass number for the beta particle, equals to 228, which is the mass number for the radium. So x is equal to 228. And for y plus negative 1, which is the atomic number for beta particle, equal to 88, which is the atomic number for the radium. So y is equal to 89. So the unknown daughter nucleus belongs to actinium-228 based on the periodic table. Gamma decay. So when atoms decay by emitting alpha or beta particles to form a new atom, the nuclei of the new atom formed may still have too much energy to be completely stable. So to become more stable, the nucleus releases its excess energy in the form of gamma ray. So in this diagram, it shows an unstable atom release its excess energy in the form of gamma ray. And the symbol for gamma ray is this. The nucleus of the unstable atom will emit gamma rays to release that excess energy. Gamma rays are high frequency electromagnetic waves. So gamma rays are not charged particles like alpha and beta particles. So it has no charge and no mass. So the mass number and the atomic number for an element of daughter nuclide do not change. Gamma ray also has low ionizing power but highest penetrating power. So it can be stopped only by a thick lead. For the general equation for gamma decay is here. Okay, now let's see this diagram. So this diagram shows the process of gamma decay. So here is the parent nucleus which is in an excited state, and this is the daughter nucleus with less energy plus the gamma ray. So let me show you the example of gamma decay. So here is the decay equation for cobalt-60. As we can see, after gamma decays, there is no change in mass or atomic number. So why? So as I have explained before, to become more stable, the nucleus will release its excess energy. So nucleus in the cobalt atom release the energy in the form of gamma radiation. So here is the gamma radiation or the gamma ray. So we can conclude that in gamma decay, it involves release of energy or gamma radiation. For your information, gamma rays are usually emitted in conjunction with other types of radiation. So for example, is radium-226. So radium-226 loses a helium or an alpha particle to become more stable atom, which is radon-222. However, the nucleus of radon-222 may still have too much energy to be completely stable, so it releases energy in the form of gamma ray. Now, to test your understanding, let's try these questions. The first one, an alpha particle is A hydrogen atom, B, the ultimate unit of positive charge, C, an aggregate of 2 or more electrons, and D, a helium atom with 2 electrons removed. The answer is D. So the second one, complete the decay equation below. The answer is bismuth 214. The third one, and for the last one, the answer is polonium 218. I think that's all for me. Thank you for watching my video. Have a nice day.